Hi guys, I'm sorry I can't be there with you today. Hopefully this will help you with some more information about the normal distribution. I'd recommend you take some notes, certainly on the first slide and maybe the examples, and then there's some questions for you to have a go at before an exam style question. So the same setup as we've been using. So I'm going to have a look at the normal distribution, but I'm going to have a look at it slightly differently to what we've looked at previously. So I'm just going to go through some of the facts. We know these, we've gone through these 100 times, but just a reminder, the normal distribution is symmetrical about the mean, and the mean, median, mode are all equal, so it's symmetrical about those as well. And that's where we get this normal distribution curve from. So there's my line, there's my bell-shaped curve, and down the centre there is mu. That's my mean, my median, my mode. 68% of all the data lies within one standard deviation, so that's sort of this bit here. 95% of the data lies within two standard deviations, so in between those green lines there. And 99.8% of all the data lies within these red lines, and that's 3 standard deviations. Now the important bit to realise about that, certainly that final point, that 99.8%, is that the normal distribution is infinite. That normal distribution curve never touches the bottom. It gets closer and closer and closer to the bottom, but it never touches the bottom. There's always a possibility that that lowest value can go on to negative infinity, and that highest value can go up to positive infinity. So sometimes that normal distribution might fit the data perfectly, but that fact about being infinite doesn't quite fit. If I'm asking you people's test scores and you can show me that it's normally distributed, there's obviously the possibility that a normal distribution says they can get below 0 on a test. In reality, that's not true. So a normal distribution could be the best fit, but it might never be perfect. So just think about that infinite point, okay? Think about what that means in terms of the data itself. The normal distribution is a continuous distribution. We know this. Data is discrete or continuous. Discrete means we go 1, 2, 3, 4, 5, nothing in between. Continuous is my weights, my heights, anything that I can measure, and therefore I can have any infinite decimal in between. That word infinite again. I can use normal distribution to describe discrete data, but to do that I have to use the continuity correction. And just a reminder, the continuity correction is if I said in my discrete data that something was 5 or 6 or 7 or 8, then to be 5, what I actually mean is anything from 4.5 up to 5.49 recurring, anything that rounds to 5. Now that becomes less accurate if I'm doing this with discrete data, and it doesn't fit as nicely if I'm using discrete data. So just be careful that if you are using a normal distribution and it is with discrete data, it won't be as accurate. Doesn't mean it's impossible, just not as good. Then there's a couple of advantages to the normal distribution above lots of other things here, in that probabilities for the normal distribution are really quick and easy to find. We've got our tables, we've got our calculators, and obviously there are computer programs that can do it instantly for us. So that's a really nice advantage of the normal distribution. And the other point at the bottom is we often forget this, and yet we use it all the time. If you are told, or you know, that the distribution of a sample is normal, it is normally distributed, then we automatically assume that the population is normally distributed as well. We make that assumption. And we do that all the time. Pretty much in every question you've ever answered, you use that fact, but you probably don't think about it. So if you want to write any of those down, just ask who's ever covering now, just to pause the video and just make any notes you want to on that. Okay, so hopefully you've got those points down. Now, I couldn't get my funky calculator to work on the screencast for some reason, so you've got a very dodgy video of me showing you my calculator, so I hope you can see this quite clearly. But what we're going to have a look at is we're going to have a look at calculating normal probabilities but working backwards. So rather than using your calculator, menu 7 and normal CD, remember we never use PD, rather than doing this to find a probability, in the questions you've got on the screen here, if we've got a probability, what is the value? Working backwards from that question. So if we have a look at example number 1 on the screen, you should be able to see that it says I have x is a normally distributed variable with 15 is my mean and 2.21, what is that? That is my variance, that is my sigma squared. So it's really important that we know those two things. And it says find x such that the probability x is less than that value is 0.05. So this is 5%. So normally, when we put things in our calculator, we would go to normal CD, we would put in our value for x, we would put in our value for mu, we would put in our value for sigma squared or for sigma, and it would give us a probability. But in this question, I've been given the probability of 5%, and I want to work backwards to find out what x is. So on the calculator, I'm going to go menu 7, just going to write this down so you can see. So menu 7, and I'm working backwards. So we've done this before, but we're going to go for number 3, inverse normal, because we're working normal. We're working backwards, so number 3. And when we get to inverse normal, it asks me for an area, it asks me for a sigma, and it asks me for a mu. So thinking about our normal diagram, and that area is asking me, I want to know in this question, less than my value gives me 5%. So down here, less than that point is 5%. So my area is 0.05. My sigma in this question, well, my variance, my sigma squared was 2.21. So my sigma is going to be root 2.21. And that's calculated it for me as 1.4866. And my mu in this question is 15. So on this diagram that I've sketched on the screen here, mu, this centre value, is 15. So whatever I get from this, I know it's got to be smaller than 15. 12.55. That's this number down here. So my estimate for x is 12.55. And that's it. That's working backwards from a normal probability. Now I would definitely recommend you write this down, but I will make sure it stays on the screen while you're having a go at some questions. And what I'm going to do is I'm going to slide the calculator across and do another example. So if you want to write down this first example, just get whoever's covering to pause the screen so you can write that down, okay? So let's take a look at example number 2. And this is pretty much the same question but just with different data. So y is my random variable and it's normally distributed with a mean of 230 and a variance of 0.18. And find y such that the probability of it being less than this value is 0.95, so this time it's 95%. So again, I'm working backwards, so I want to go menu 7, I want to go 3, inverse normal. So menu 7, 3, inverse normal. Obviously all the information that's on my calculator is from the previous question because I haven't cleared my screen. But let's just think about this normal curve. You know how much I love a normal curve. There's my curve, and this time it's 95%. Now it's still less than, so that means if I draw my line up there, 95% of the data is up there. That's down there. So that's 95% of all that data is to the left hand side. It's less than my line. And my mean in the centre here this time is 230. So the area I want for this question is 0.95. The sigma I want, again, we were given 0.18 as the variance, so I want to do root 0.18. And my mu this time is 230. So hopefully you can see that in the calculator. And if I press equals, can you see that clearly? 230.70. And that looks right because it's got to be more than 230. It's not going to be much bigger than 230 because my variance or my standard deviation is so small. So that gap is not going to be as big. So again, I would say, can you write that second example down so you've got it to refer back to? So hopefully you've managed to have a go at copying both of those down now. And what I'm going to ask you to do is have a go. There are 4 sets of questions on a sheet for you to have a go at. So if you can have a go at those first. The answers are on here, so I'm going to ask you, whoever's covering, to pause the video, and then after you've done each set of 4, so when you've done X, when you've done Y, when you've done Z, when you've done A, whoever's covering can just play the video and show you the answers to those. And then last 15 minutes of the lesson, like we've been doing, I want you to put everything away, exam conditions, have a go at the exam question. Then give that in at the end of the lesson and I'll have that marked, and I should see you tomorrow in the lesson. Okay, so if you want to pause the video, have a go at the questions, and then play the video when you want them answered. So that's the answers to the first 4 for X. Obviously for this question, my mean is 26 and my sigma squared is 4.3, so you should have used root 4.3 for sigma. And the only thing that's different for each question is your area. 0.05, 0.1, 0.9 and 0.95. And for the second question, for Y, again we've got 84 is our mu value. Just be careful with this one. Sigma squared is 1.6, so sigma, we don't need to square root this one, we just use 1.6. Because the variance is sigma squared, so we shouldn't be square rooting 1.6. So just be careful on that one. And I've got Y is 81.37, 81.95, 86.05 and 86.63. For the third question, your Z values, again 46.5 is my mu, 9.52 is my sigma squared, so for sigma we should be doing square root 9.52, and then changing the area for 41.42, 42.55, 50.45 and 51.58. And if you've got this far, the answers to the last question, the A's, my mu again is 105.7. My variance, my sigma squared, is 5.48 squared. So the variance is 5.48. Don't square root that one. Oops, 48. And then just changing the area to 96.69, 98.68, 112.72 and 114.71. Quite a nice simple task once you're used to that calculator method, but it's just knowing what you're looking for. So knowing your mean, knowing your standard deviation, knowing your area, you should be fine. Okay.